So a linear inequality means we still are dealing with a line, but there are some lines that just go on forever and they have the same y coordinate. So y equals 5, y equals c, is saying that it doesn't matter what x is, y will equal 5, no matter where you are across the horizon. It can be anywhere on the y line. If y equals -4, your line is going to go right across all the x's possible, but it's going to stay no higher, no lower than -4. Same thing works when you have x. If x is equal to -2, then x will be equal to any y coordinate as high as you want to go, as low as you want to go. It's a line that goes on forever, but it is always on -2. In this case, if x equals 4, just find where x is 4 and draw a solid line straight up and down. So now we're going to look at a region. A region in a plane is described using an inequality. So if I shade in a region, that's going to mean that anything in that region could be the answer. So for example here, I've got a dashed line, and that dashed line is used to show that the points are not included. So if y is no longer equal, now we're using y is greater than 2, we'll look and draw a dashed line where y equals 2, and because y is greater than 2, it's going to be anything in this shaded area. So y could be 3, y could be 4, y could be 2.5, y cannot be 2. It's not allowed. And it cannot be 1 because that's less than 2. Y's got to be greater than 2. This one, the line is solid because y is less than or equal to -1. So we find where y is -1, and we draw a solid line there. This is a little bit similar to when we looked at inequalities and we had an open circle if it didn't include that number, or a closed circle if it included the number. And then y could literally be anything down in this region. Similarly with x, if x is less than -3, it's a dashed line where x equals -3 all along this area, and then we shade in anything that's less than. So if this Cartesian plane went to -10, we would shade that in as well. If x is greater than or equal to 4, we have a solid line where x equals 4, and we shade in after that. Now this is where it gets really fun. So now we've got a version of y equals something x plus c. We've just got it around the other way. We can still use this to solve our equation, but let's look at it. So if 2x plus 1 is less than or equal to 5, then we're going to consider that y, there's our y, if y equals 2x plus 1, then the region is y is less than or greater than 5. So there's our 5. Y is that. Less than or equal to 5. What did I say? So they'll all be the x values that are on this line here. So we'll color in the line down here, but we're going to start here at 5. And it says equal to, so we're going to make that a solid line where y is equal to 5. And then this whole region is possible. But now we've got an equation. We've got an equation that says 2x plus 1. So that means that this is going to make a line. So it'll have to be something that fits y equals 2x plus 1, but it can't be up here. It can only be in this area. So for this example, x, on the line that we have where y equals 5, x is equal to 2. And we have an equal sign in there. So the solution for this is going to be, you're looking at it with me, x is less than 2. And it's less than or equal to because we include that in the line. So x can be anything in this equation that's less than or equal to 2. Let's do one. So find the rule for this one. Here we go. Find the rule for this horizontal and vertical line. The rule for this line, so for this one, it doesn't matter what x is. X is going to be lots of things. Y is always going to be -3. So we know this because y is -3, and we know that this line goes on perpetually. So x can be literally anything, but y is always going to be -3. So we've agreed that we're going to call that y is -3. For this one, y changes, so we know that x is going to be equal to 7. No matter what y is, all as high as y goes, as low as y goes, if y is 0, x will always be 7. So that way we can say, that's our shorthand of saying, okay, we know that that's going to be a vertical line, and it's going to cross through where x is 7 forever and ever, amen. Now we're going to sketch the following regions. So y in this case is going to be greater than or equal to -2. So here's -1, -2. There's our point for -2. I'm going to draw a solid line because it is not just greater than, it is greater than or equal to -2. So that solid line, I'm going to label, if I can squeeze it in there. This is where y equals -2. X can be anything. And then I'm going to shade in, is it greater than? Yes. Y is everything, and you can go through and make a nicer shade, that's above that line, including that line. So for this one, X is going to be less than 5. So I count 1, 2, 3, 4. That's 5, isn't it? 1, 2, 3, 4, 5. So here X equals 5, but the region where X is less than 5, I'm going to shade this whole area. And notice that it doesn't have an equal to sign, so I'm just going to put dashy dash lines. Dash, 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 dash. So that's sort of the boundary, but it's not included. This is where X is equal to 5, but we're shading the region and showing with our dashed line that anything less than 5 is the answer. That could be X is 4, X is 3, could be X is 4.5, could be X is 4.9. It just can't be 5. So the first one had an equal to, so it's solid. The second one is dashed. Now, similar to that example up above, solve the following inequalities using graphs. So we've got a graph here, and we know that this is our y. So y is going to be less than or equal to 2. If there's a line underneath, it can be 2. So when I set my boundary at y equals 2, that is going to be a solid line. So that's where y is equal to 2. But we want to find out what the solution is along this section. So I'm going to color in this section. What's above that line, is it less than? Yeah, less than or equal to. Above that line, it doesn't matter. So x can be, where's the point here? This is where x is 1. So the solution to this, so I can use any x in there to get along that line as long as x is less than or equal to 1. Because it's 1, it could be 0, it could be -1 down here, it could be that line goes on forever. So that's really sloppy. X is less than or equal to 1 will satisfy that equation. For this one, -x plus 1, we're looking at -x plus 1 is greater than 3. So that means that y has got to be greater than 3. Where's 3? Here. Do I put a dashed line or a solid line? There's no little under arrow there, so I'm going to put a dashy line there where y is equal to 3. So y is going to be greater than 3, so I'm going to color in the region if I want to color in the region, but really I'm only worried about this line, anything that falls on this line. And so that line, is it still greater than? Yeah, it's greater than. So that means that line happens to appear where x is -2. So that tells us that the solution for this is going to be x is less than -2. So anytime I put in something that's less than -2, that will be on that line if I use that equation.